Okay folks, solving linear systems, the graphing method. The only reason I really want to do this is to show you what's happening. I will show you other mathematical ways that work a lot better and a lot faster. Okay? Let me show you this first. Now we've already learned how to take an equation and change it into slope-intercept form. But think about this for a minute. This is a line. When I graph it, I get a line. And every point on that line is a solution to this equation. Okay? When I graph this line, every point on this line, the green line, is a solution to that equation. What about where the two lines cross? What do we know about that point, Kyle?
That's the mean.
Well, it is an intersection point, that's true, but what do I know about it? If every point on the red line, if every point on the red line is a solution to this equation, and every point on the green line is a solution to this equation, let's just say that they look like this. Okay? What do I know about that point where they meet? What is that point, Parker J? It is the intersection point. Kyle said it. James?
It's the solution for both.
It's the solution for both of them because it's on both of the lines. And that is the solution of the system. A system is just more than one equation. Okay? So we're going to graph these two to find out what point solves both of them. Okay? Now, let's take this first one. Remember, y is equal to mx plus b. We want to change both of these so that they're in that form. We'll start with 2x minus y is equal to 8. I want to get y by itself and I want to make it positive. So remember, we're going to subtract 2x from both sides. And now I have negative y is equal to negative 2x plus 8. But I don't want y to be negative. I need it to be positive. So I'm going to multiply this side by negative 1 and this side by negative 1. That's going to give me y equals 2x minus 8. What does the number in front of the x represent?
Slope.
The slope. What is the number in the back by itself, the constant? What is that?
Y-intercept.
That's the y-intercept. Okay? So if I'm graphing this line, I'm going to go down to negative 8, which is right here. And to find the other points, I'm going to use the slope. Go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I'm going to keep doing that, and I'm actually not going to draw the line yet. I'm going to see if when I graph the other line, Sophia, if there's a point that falls right on top of it. Because if there is, then that'll make it easier for me to see than if I'm drawing the line. Okay? Let me take this next one. Okay? Help me with this one, Clay. It starts at x plus y equals 1.
Let's get x on the other side.
Let's do. How do I do that?
Subtract x.
Subtract x. So now I've got y is equal to negative x plus 1. Do you agree? But what's in front of the x?
1.
Not 1, but what?
Negative 1.
Negative 1. And I like slope to be in a fraction, so it's negative 1 over 1. Okay, well let's graph this line. The y-intercept is positive 1. And it says go down 1 and over 1. 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 Do you see that this point is common to both of those lines? What are the coordinates for that point? What are its x and y?
3, negative
3, negative 2. 3, negative 2 solves this equation and that equation. It's a solution to the system. Okay? So if I were to actually draw the line, it looks something like that. The red line looks something like this. But do you see when I have just the dots, one fell right on top of the other. It was easy for me to see which one they had in common. All right? Nice job. 20 seconds. Jordan, what you got?
Would it be possible to solve this without the graph?
It is. I'm going to teach that tomorrow, and it's much easier. But I want us to have a visual idea of what's happening. It's where these two lines hit each other. Good job. Let's look at the next video.